This video is going to cover the second half of Chapter 4, Section 2 notes, which was the unit circle. So we talked about the unit circle in the last video, but just a refresher on it. This is the circle that is the result of a radius being 1. So remember, we move to the right 1, we move up 1, we move left 1, and we move down 1. And the result are the coordinate points in between. So we went over how to find the degrees around the circle, and that is the 30, 15, 15, 30 rule all the way around, 30, 15, 15, 30, all the way to doubling back to that 360. Then we went over how to find the radians. So we start 0 on the right, pi over 2, or a half pi at the top, pi at the left, 3 pi over 2 on the bottom, and doubling back around to 2 pi, which completes your circle. Then all of the angles nearest the x-axis are your over 6s. All of the angles nearest your y are over 3s. And the ones in the middle are the over 4s. We said the trick to remember the numerator is in the first column, it stays pi. I'm in the first quadrant, sorry. Second quadrant, it's 1 less than the denominator. Third quadrant, it's 1 more than the denominator. Fourth quadrant, it's 1 less than double the denominator, or we memorize the pattern 5, 7, 11. Then we filled in our coordinate points. So remember, every over 6 has the coordinate point that is root 3 over 2 and 1/2. Every over 4 has the coordinate point root 2 over 2 and root 2 over 2. And every over 3 has the coordinate point 1/2 and root 3 over 2. Then what changes as we move around that circle is the positive and negative signs on them. In the first quadrant, these are all positive. In the second quadrant, my x is negative, my y is positive. In the third quadrant, they're both negative. And in the fourth quadrant, the positive x and the negative y. And then you've got your core points moving right to 1 is 1, 0, up 1, 0, 1, left 1, negative 1, 0, and down 1, 0, negative 1. So again, that's the unit circle, and that's going to help us with some application moving forward. So we left off on domain and range of sine and cosine. So the domain of the sine function and the cosine function is the set of all real numbers. The range of these functions is the set of all real numbers from -1 to 1 inclusive. So this means as we go around our unit circle, we'll always get a coordinate point for sine and cosine, which is the y and the x, that is from -1 to +1. Our sine and cosine will never be less than -1 or greater than +1. The second part of this says that sine and cosine are periodic, which means that the pattern behaves in a repetitive or cyclic manner, and each period is 2 pi. This means that every time we go around our circle, which is also a coterminal angle, that point is the same. So let's just start with the 1, 0 coordinate point. If I'm at 0 and then I add 2 pi to it again, I get 2 pi. Add 2 pi to it again, 4 pi. Add it again, 6 pi, 8 pi, and so on and so forth. So the coordinate points of all of those angles are 1, 0, which means the sine and the cosine and the tangent are always going to be the same. If we look at the coordinate point on the left, which is our -1, 0, and the angle that's there is pi. If we find coterminals to pi, it's pi. Add 2 pi, it's 3 pi. Add 2 pi again, it's 5 pi. Add 2 pi again, it's 7 pi, and so on and so forth. So notice that all the even whole numbers fall on the right, and all the odd whole numbers fall on the left. So this is going to help us determine our signs of our positive and negative angles, or positive and negative coordinates, as we move around our circle beyond the 2 pi, or if we are negative. All right, so example 4 said evaluate the trig function using its period as its aid. So all this means is that it's going to either be bigger than 2 pi or less than 0, and we've got to figure it out based on that. So if I take sine of 13 pi over 6 and I convert this into a mixed number, I get 2 and 1/6 pi. So picture my unit circle again. We said the even whole number falls to the right. So I would go all the way around one time, and this would be 2 pi. Now I just have to add 1/6 to it, which is less than a half, and that puts me at the over 6 that falls in the first quadrant. I know because it's an over 6, it's a root 3 over 2 and 1/2. And because it's in the first quadrant, my y, which is the sine, stays positive. So the sine at 13 pi over 6 is 1/2. Look at B. B says cosine 5 pi. So I could take the time to go around my circle 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and end on the left. And I know that that coordinate point is negative 1, 0. Grab the cosine, which is the x, and I get negative 1. Or, remember what we went over on that last slide, even whole numbers are on the right, odd are on the left. So 5 pi is probably not that big of a difference, but if I gave you something like 13 pi, you don't want to have to go around your unit circle a whole bunch of times to figure out that that coordinate point is still negative 1, 0. This will definitely help you with your time on things like that. Even and odd functions. So cosine and secant, which is the reciprocal of cosine, are even functions, which means the positive and negative version of the angle still gives the same cosine or secant. So what this means, if I say, what's the cosine of, let's say, pi over 6, it's going to be the same as the cosine of negative pi over 6. And this happens because cosine is our x value. So if I'm looking at pi over 6 and I'm looking at negative pi over 6, my x is always going to be positive. So that's not going to change. Same thing if I did 5 pi over 6 and negative 5 pi over 6. This time the cosines would both be negative root 3 over 2. So I think of it as even, being that even if I change the sign on the angle, it doesn't change the sign on the value of cosine or secant. Sine, cosecant, which is the reciprocal of sine, tangent and cotangent are odd. If I change the sign on the angle, it changes the sign on the trig function. So if I were to look at pi over 6 again and I say sine of pi over 6, again, it's over here in my first quadrant, root 3 over 2 and 1/2. So the sign there is 1/2. If I tried to find the sign of negative pi over 6, it's down here, right, which is root 3 over 2 and negative 1/2. So that changed to a negative 1/2. So you'll see this with actual angles, and then you'll see this with values like we're about to do in an example where you don't necessarily know the angle itself, but you're given the sine or the cosine or the tangent or the secant or the cosecant or the cotangent, and you have to know which one to change the positive or negative sign on. So again, cosine and secant do not change sign. All the others do. These fundamental identities, we already know the reciprocal identities. That sine is the same thing as 1 over cosecant. Cosine is the same thing as 1 over secant. Tangent, 1 over cotangent. Cosecant, 1 over sine. Secant, 1 over cosine. Cotangent, 1 over tangent. So this just helps with the next example. Again, a refresher on these are called your reciprocal identities, but these we already know. So example 5 says, use the value of the trig function to evaluate the indicated functions. So we're giving you one of the trig functions, and you're asked to find the additional ones based on the angle or the opposite of the angle. So if I look at A, it says the cosine of t is negative 1/3. Now what it's asking for is the cosine of negative t. Because cosine is even though this sign changed, the value here does not change sign. I keep the negative 1/3. And then secant of negative t is based on the cosine of negative t. Remember, secant is the reciprocal of cosine. We use this cosine because it's negative t, and I just take the reciprocal, which would be negative 3. Looking at B, sine of negative t. Now I'm asking for sine of t. So sine, remember, is odd, which means if I change the sign on the angle, I change the sign on the trig function. So I go from negative to positive t, which means I'm going to take my positive 3/5 and I'm going to make it negative. And then I want the cosecant of t, positive t, so I'm going to take the sign of positive t, and I'm going to flip it, negative 5/3. If it had asked for the cosecant of negative t, then I would take this and flip it, which would be a positive 5/3. So pay attention to the sign, the positive negative sign on the angle itself. And remember, if it's cosine or it's secant, we leave the positive negative sign how it is. And if it's anything else, we change it. All right, good news is last part's the easiest because our calculator does the work for us. Example 6 says use a calculator to evaluate the trig function and round your answer to 4 decimal places. So here's the biggie in this section is that we have to pay attention to the mode on our calculator. If I'm asking for the trig function, whether it be sine, cosine, tangent, cosecant, secant, or cotangent of a degree, so if I said sine of 30 degrees, for example, then my mode has to be in degrees. If I'm finding it of anything that doesn't have that little degree symbol, which if we look at all the examples that we're about to do, then the mode has to be in radians. So on our graphing utility, we're going to click on mode and notice that third line down that I can change. It's actually the fourth line down, but normally it starts at normal. So the fourth line down from the top is radian and degree. So for these examples, because they're all radians, I want to be in radians, but let's just say I wanted to find the sine of 30 degrees. I'd have to click degree, get out of this menu, and click the sine of 30 degrees, which should be 0.5. Remember, 30 degrees is my over 6, and that y is 1/2. Now I want to go to radians because these questions are in radians. Go down, change it to radians. Get out of that menu. Secant is not a button I have. I have sine, I have cosine, I have tangent, but I don't have secant. But we just went over these reciprocal functions. Remember, secant is the same thing as 1 over cosine. So I'm going to do 1 over the cosine of 4.5. 1 divided by cosine 4.5. And I'm going to round it to 4 decimal places, which is negative 4.74392. So it stays as negative 4.7439. Now I go to B, and B is cosecant. So this is 1 over sine of 0.9. And again, there's no degree, so I know it's radians. 1 divided by sine 0.9. And I get 1.2766. I go to C, which is still in radians, tangent. This time I have the button. I have to use pi though. So when I click tangent, which is there, pi is above the caret. So I do second pi divided by 2. You don't ever want to do 3.14. You want to find the pi button. And this should make sense because what's happening at my tangent at pi over 2, which is at the top, is the coordinate point there is 0, 1. So if I did y over x, 1 divided by 0 is undefined. So your calculator is giving you that error because it doesn't know how to find undefined, which would be the answer for the tangent of pi over 2. Okay, last one, and this is cotangent. So again, we don't have a cotangent button. We're going to do 1 divided by tangent, negative 1.2. 1 divided by tangent, negative 1.2. Enter. And I get negative 0.38877. So 3888 would be the rounded version of that number. So it's a big deal to pay attention to your mode on these questions because you will find an answer and you will have no idea it's not the right one. It looks like it's an answer that would work, but if you're in the wrong mode, it's going to give you the wrong answer. So be very, very careful and pay attention to your rounding. Some of you lost some silly points on the test or quiz from the test from the last chapter, just from simple rounding. So pay attention because it will tell you what to round to. Usually on things like this, it's 4 decimal places. All right, guys, that's the end for today. Okay, remember to submit your notes so you can get full credit for them. It would be awesome if you could submit just part 2, so it's less slides for me to click through for today. When you export from Notability, you can select the page range. And so you only have to select the pages that you filled out today and then turn those in again before the class period ends. Have a great day, and I will see you tomorrow. Bye, guys.